This event tonight, Seeding Innovation, is all about recognizing the creative talent that lies here within our community, about bringing that talent out into the open and offering it to a younger generation, bringing people together to work on problems and in the process learn something new and gain some new skills as they go. And that is the motivation for a new program at UCSC in the Baskin School of Engineering called IDEAS. Impact Designs, Engineering and Sustainability through Student Service. And the IDEAS program has been working with the youth at the Natural Bridges Green Careers School to imagine something new. We're here to celebrate that. Ultimately combining their youthful vitality and energy with the resources, the perspective, and the experience of the community mentors that they are working with to design sustainable technologies and systems that will show us how together we might just be able to turn this around.
The potential of getting a supercapacitor that is on par with lithium-ion means that we have a much cheaper source, a green, easy-to-produce source of energy storage. Lithium-ion batteries are not particularly easy to work with, and the lithium-ion itself can be poisonous in cases. And then you have disposal issues, and you have lots of issues with thermal management, of thermal runaway. There's all these issues that will be solved by coming up with a supercapacitor that is on par or better than a lithium-ion battery.
Our project is focusing on creating a renewable energy storage solution that uses some low-tech materials that are non-toxic, and basically anybody with some moderate chemistry knowledge can be able to put this thing together. We want to create an alternative to things like lead-acid batteries or lithium-ion batteries with something that has a higher energy storage capacity and that's made of materials that are more renewable.
Ted is a very generous man. He was interested in this project for a while now, and he basically contacted us, chemistry students, see if you're interested in this, and the ones who got the message, we came in here and then we started from that.
Well, I don't have a background in chemistry, and my background wasn't engineering, although I was always very interested in engineering. My schooling was a variety of things, but I ended up wanting to go into international trade and international business. Then later I got involved in venture capital and angel investing, and I became the manager of the Monterey County chapter of the International Angel Investor Institute. So I did some investing and did okay, and so I retired kind of early, and I started to research energy storage, which arguably is the most important issue of sustainability. I just wanted to get involved, and I figured if I could come to UC Santa Cruz and bring some of the research that I have found, looking for a way for us to build a supercapacitor. In our case, what we wanted to do was to build a supercapacitor that anybody could build in their kitchen. So I made contact with UC Santa Cruz, showed them my research, told them my idea, and started to work with the IDEAS group.
Basically, the project was trying to use graphene nanostructures to improve the supercapacitive capabilities of manganese oxide, which is known to be a good supercapacitor material. And from there, Ted did a little more research, found simple ways to synthesize these graphene nanostructures, and then from there, the graphene supercapacitor project emerged.
One of the most interesting aspects of our project is the materials that we use, specifically graphene, or graphene oxide. It's kind of this new wonder material that's only recently been talked about. I mean, it's only been known for a couple of years now. Just got a Nobel Prize a couple years ago for a guy who made graphene by taking off pieces of graphene from graphite using Scotch tape. You know, it seems kind of low tech, but I think it kind of like talks about like, you know, how amazing this material is.
All graphene is a rock of graphite whittled down into layers. And if you whittle it down to, let's say, 7 layers or less, then it's called graphene. And it's put into flakes, and it creates a surface where you have the ability of it to carry electricity lightning fast. It's unbelievable. It's also the hardest substance in the world, harder than diamonds.
So we have 5 test tubes, each with different chemicals. One has graphene oxide, one has manganese sulfate. 2 of them have washes. We rinse it with deionized water, and the other one has sodium hydroxide. Basically, we dip a stainless steel substrate into each one of them. That way we can stack layers of each chemical onto each other. And each cycle takes about 4.5 minutes. So we do that 100 times to have 100 layers of each chemical.
The goal of all of these dippings and, you know, dryings of this like with this steel substrate, this like steel bar basically or plate, is just to generate one of the electrodes that are going to be required for the supercapacitor, right? So you're going to have one electrode and another electrode basically dipped into electrolyte solution and allow a circuit to be generated. Basically, to allow charge to move from one side to the other, and eventually you'll get work out of that. In a nutshell, I mean, it sounds simple, and that's because it is simple. You know, we wanted something that was really low tech, as I said before, and something that, you know, someone can do in their garage. We don't want to have to require people to need an advanced, you know, chemistry laboratory or a PhD to, you know, run it for them. So this is the simplest as you can get.
Basically, you sweep the voltage applied to the electrode that's made of your material, and you see the current response that emerges from it. And based on that current response, you can get a value for the total capacitance of your material. But from that analysis, from that response, you can essentially quantify how good your material is at being a supercapacitor. So basically, we tried this first cyclic fault tolerance experiment. Didn't work out. TensorStat said it was overloading. That means there's too much current running through. Quite easily explained by the fact that our counter electrode has been soldered together with tin before. It's snapped. It's a snap platinum electrode. I had a feeling this would happen, and that kind of confirmed it. I'm gonna have to go get a new, clean, and unbroken electrode, and we can try this again. I'm sure it'll work out better this time.
We ended up with what we consider success, and that is to replicate the key component of the supercapacitor. We're now at a stage we've got to improve our graphene production, make it cheaper and quicker and easier. And once we've done that, the door is open for anybody to create a phenomenal supercapacitor.
We discovered that the supercapacitive capabilities of the manganese oxide material that was originally used was improved beyond what was found with just graphene oxide precursors, like commercially available graphene. And that just pretty much opens the door, like, wow, we don't need to have all these crazy instruments, these $1 million like labs to make something that is like the next leading material in the world as far as, well, not just energy for anything. Graphene is like the new hot material, probably be incorporated in almost every technological device in the near future. And like I said, that can be made essentially at home.
There's enough people out there, I'm dealing with them right now, of building their own electric cars and building their own batteries and supercapacitors. You look on YouTube and you can see them doing it. And that just could be the breakthrough. Who knows? Let's find out. That's what we're about. Let's find out and make it available to everybody.
We're running out of resources. So especially here in California, we're running out of water. So the smart thing to do is to optimize the amount of crops that you can get from as little water usage as you can. I'm part of the microgrid sensor design project. Microgrids and sensors is one of the best ways to actually compensate for whatever is going to be coming our way in the future. Our main stakeholder is the UC Santa Cruz farm. The whole point of it is basically having to provide the farm with cheap, reliable sensors so they can do smart farming. And we're implementing a weather station for the farm. Like this. So this is gonna measure wind turbulence, precipitation, wind direction. So this is prevalence of the wind. There's that assumption that like all it is just you give it a couple seeds, get some topsoil, like throw some water, find some like good sunlight, and then you'll be able to grow crops or whatnot, right? With smart farming, on the other hand, it's basically you're able to address all the resources that are there and utilize everything to its optimal capacity. The climate here on this mountain slope, between up there all the way down to the farm, you have a difference of maybe 10 degrees Celsius, in climate change. It could be that drastic. You want a certain amount of humidity, lighting, certain amount of water, whatever resources, you're able to analyze the type of environment that you're in, where you're farming, and you can find out which crops will work best there. So with sensors, it becomes more organic, so it can respond to real-time changes. So technology can do humanity great good if we know how to use it, when to use it. It's a double-edged sword.
There's a lot of the workforce that's already been, opportunities there that were eliminated with industrial farming, that kind of killed off a lot of the roles that were there. And I don't know, maybe smart farming can help to reclaim some of those roles. I think the industrialization of farming is god-awful. I guess smaller scale independent farming is an interesting topic to me. I'd like to see that continue and grow, and this could be really huge for that.
When it comes down to it, we are a sensor design team, and we want to utilize this technology for the greater part of humanity. We have been in an energy crisis for a long time, and there's no way of escaping that. We're going to be running out. If we don't change our habits, we're going to change the climate permanently. It's a harsh reality that we live in. Everything's intertwined, and it's much more apparent that we cannot escape that every human life on this planet is connected. We're intimately connected with our planet, our finite planet. We can only do so much with it, and the Earth is going to rebound. It's going to reject us in some way, somehow, and it's going to be desolate if we don't change our ways.
I think smart farming could make small-scale farming more of a reality, more of a possibility, more plausible, and I think that could be a catalyst for more change.
The concept of waste energy really addresses like two of society's big issues. First off is waste generation, and the second is energy dependence. Because human society, as you know, as populations continue to grow, we are also contributing a lot more waste to our landfills, and these landfills actually have capacity. So waste to energy not only is a method for waste management, but energy recovery as well. There's actually a number of technologies that fall into that category, like gasification or pyrolysis is a new one. And the one that I actually studied and focused on was anaerobic digestion. And so with anaerobic digestion, there's an array of feedstocks that fall under that. And a feedstock is simply whatever material you're going to feed into your system. And so an anaerobic digester, meaning anaerobic, meaning with lack of oxygen, digester, meaning breaking things down, is if you picture an apparatus, an enclosed apparatus that is airtight, and what it is it creates an environment for the microbes, which are anaerobic bacteria, to digest whatever feedstock you're putting it in into a gas, a biogas. And you're able to sequester that biogas and harness it to create electricity and or heat. So it's just a better option than taking whatever feedstock you had, whether it be food waste, yard waste, agricultural waste, and just throwing it away into a landfill. So not only does it divert waste from taking up space in the landfill, but it also sequesters those harmful emissions that would otherwise just leak into the air.
My name is John Bombaci. I'm the wharf supervisor for the City of Santa Cruz Parks and Recreation Department. I'm in charge of maintenance and operations on the wharf at Cal and Main Beach. We have trash compactors and recycling areas, and the trash is compacted in a sealed compactor unit that is then pulled onto a truck and taken off. The trash is compacted to reduce the number of trips that the roll-off trucks have to make out onto the wharf, take it off. We're certainly considering other options, as it is pretty hard on the wharf structure and certainly on the wharf paving. The waste assessment is another element of that. We're looking to see what the feasibility is of converting our waste stream into a fuel stream. We would be able to contribute significantly, but it would, if we were going to set up a viable waste to energy facility in the area, it would have to include some other large users, the hotels in the area and the boardwalk. We're looking at different systems that would do that in the most environmentally responsible and sustainable way. Looking for ways to lower our carbon footprint and to try to find a way to be energy neutral. And so to that end, the university has been giving us a lot of help with that.
That's what we know we have to get rid of, is this mix of organics, paper, compostable, cups, clamshells, and paper towels, weird sort of cardboard that's not really recyclable as cardboard or paper. That's what we're faced with, and we can't really get composted by itself. We have to keep it with the food scraps as a compostable mix. So that's what we're after and what we're working towards. We use those for recycling. Those are full of recycling, and we'll truck those to the recycling center. And so, but the other thing that we use the roll-off truck for is the compactors that are full of the organics. This whole unit here is a compactor.
Okay.
So you see how it's on wheels and it's got this cable system in the rails. That truck pulls right up here and picks this whole thing up and takes it to Marina. Even though they have this compost facility and recycling, there's a lot of compostable stuff in the trash right here, right next to that. Over there, paper towels, in there, paper towels, see that brown paper? Mm-hmm. All that could be composted and not even be in here.
I'm here at UCSC's Caspis Farm working on building a compost water heater. This is looking at how we can take some of our organic waste stream and mix it with manure to create heat through the decomposition process and composting, and then to use that heat to heat up water, which will travel through these heat exchange coil tubes, and the water will heat up as it flows through the compost pile. Then through the top heat exchange coil, which isn't on yet, the water will flow down and over to these showers right here, and hot water will then come out where you can take a compost heated shower using compost energy. No fossil fuels required, and we're creating energy out of our waste. So right now we're doing a compost feasibility study that's campus-wide, and it's looking at what is the potential of putting a composting facility on campus. They're working with the city of Santa Cruz to decide what's the best way to deal with our organic waste stream. And I think that if composting is considered on campus, that capturing the heat from that composting seems completely logical. It's economically incentivized, it's ecologically incentivized, and it just looks good for a lot of different possibilities.
I'm Elisa Martinez. I'm a fourth year at UC Santa Cruz, and I'm an environmental studies and economics major. My project team is doing a waste to fuel feasibility study. Initially, we were going to do it for the wharf, the Santa Cruz Wharf, but we realized that it's probably more feasible to do it for the city, if not the county. And we're also working with the campus to see what waste to fuel technologies would be best for the campus and how we can integrate that with the city. We did a waste assessment on the wharf where we sorted waste into different categories and weighed them to see how much of each type of waste we had. And it was really messy, and what we found a lot of was food, but it was like contaminated and really wet, and it would be interesting to see how we could implement like a more robust composting program on the wharf with those hurdles.
Hey, you guys, come on in. We got we got a guest speaker today.
It's all about using things that would be thrown away to make energy. So you're getting more bang for your buck instead of putting something in a landfill where it's just going to sit forever. You're taking it and you're using it to make energy, which you can sell to people. So it's economically incentivized.
Really, I don't know, waste is not really one of those things that you think about on a day-to-day basis. I mean, how many of you know where your waste ends up? Like, if you were to take candy, open it up, take out the wrapper, throw it in the trash can, where does that go? Does anyone know?
Try the NBGCC2 and it's Go Green 1. Yeah, just all one word.
Alright, everybody sit up.
Okay, we there?
Yeah.
What school are we at right now?
We're at Natural Bridges High School.
My name is Angel.
My name is Zaya.
My name is Jade.
My name is Sergio.
My name is Numa.
My name is Max. Sustainability is like sustainability.
Sustainability is using something and not having it run out. Is when you have a resource and you're able to keep that resource coming your way.
Meeting the needs of the present while not compromising the needs of the future.
Is sustainability important?
Yeah, it's very important. If we could keep something going and maybe sustain our water supply, then maybe this drought could be over. Because otherwise we'll just dry up the earth.
Yeah, if we don't start practicing more sustainability as a culture and as a like international community, then we're all gonna die.
Like visual evidence that people can be like, no, look at this, and then you have to drive by this reservoir every day, and it kind of makes you think about more of your water consumption. So, you know, there's a silver lining, I guess, with the drought and all the low reservoirs, whether it be flooding, whether it be droughts. Just it seems like our weather conditions might be getting a little more extreme, and drawing attention to that necessarily isn't a bad thing. I think it's good that it's becoming pointed out to people, and that they can kind of be more aware of their consumption and who's using water and when they actually needed it. It looks gross. It doesn't look appealing. People don't want to see that. They want it to be full. They're used to this like beautiful blue water that you can go swim in and whatnot. So it's the ugly truth. It's real, and it's not getting better. And
Santa Cruz's situation is unique from most other communities in California in that all of our drinking water comes from local rainfall. Many of the other communities in California have water through the State Water Project or the Colorado River. We have no other sources here other than what we receive from local rainfall. The city of Santa Cruz looked into desalination as a supplemental water project, and the community was not in favor of it. And so this past fall, the city council appointed a water supply advisory committee, which is made up of citizens and residents of Santa Cruz and Live Oak, and it will be up to them to evaluate future water supply projects and decide which is the best fit for Santa Cruz.
My name is Devin Friedfeld. I am a recent graduate of UC Santa Cruz and an alumni of the IDEAS program. I am currently starting my own business called WaterWise, and we are installing laundry to landscape systems and rainwater catchment systems. Rainwater catchment systems is a great way to conserve water. So basically, it's a system that uses your roof and your gutters to collect all the water that comes off of your roof from the sky, instead of having it go down a drain and getting put into the sewage system, or a drain line or stormwater line that would run it out to the ocean, or a sewage line that would take it and process it and use a bunch of energy and chemicals to treat it. You basically can collect that water and use it for your garden, use it for indoor non-potable use like your toilet, your washing machine, or you can just even collect that and try and spread out and percolate into your ground to recharge the groundwater. So basically, water collects in the gutter, comes out a downspout. Instead of having that downspout run into a stormwater drain, you kind of cut the downspout up at the top. You put like a filtration, it's called a leaf eater, just get the big chunks of whatever leaves, all that stuff filtered out. And then it goes into a pipe system that would then funnel that water through the pipe into the tank, as you kind of see here. I know it looks funny and it seems hard to believe, but it's gonna work. getting the opportunity to come down and work with the students at Natural Bridges Green Career Center really opened my eyes to the way that the schooling is working and the way that students are becoming more aware of these issues and how they are getting prepared to kind of take on these issues. These students are taking their time to come out of a conventional high school and be working at an alternative high school where they can really focus on careers that can hopefully move us to a more green world. So it's really exciting to see their excitement and to hopefully pretend like I'm giving them some encouragement and show them that this is a good career choice and there are going to be jobs for you.
I think the Green Career Center, that whole curriculum and program is great. I mean, it's awesome. And it should start with the next generation because it's going to be your water. We're burning it all up. We leave you without water. I mean, you can't live without water. I mean, it's one of the most important